I swear to God, the hardest problem in computer science is audiovisual technology. Hi. Well, it's very bright up here. I can't believe that there are people here. It's like Friday, and you guys should be drinking. What the hell are you doing? Well, welcome to my session on observability, and it's not just an ops thing. How many of you self-identify as software engineering humans? Sweet. How many of you identify as operations? Not many. Oh, good. Perfect. Well, I come from operations. I've been a software engineer. I've been a DBA. I have been engineering manager, currently the co-founder and CEO of a company. But my heart always belongs to operations because I feel like that's where computer science meets reality. And that's where I like to sit. This informs how I feel about software. Code is fine, but code, in my experience, causes problems, and I don't like problems. I like the way my friend PVH puts it is the best code is no code at all. Second best code is code that someone else writes and supports, but you get to use and read. And the third best is literally anything else. So, oh, and I have a new book out, Database Reliability Engineering. And if any of you happen to have it, so you notice there's a horse. You're not allowed to have mythical creatures as your O'Reilly book cover, and we wanted a unicorn, so we made a horse, and I have stickers that will make it into a unicorn for you. So, see me after class. Highly recommend. You can also put it on your laptop. It's very cute. So, I've been doing ops. I've been on call since I was 17. Half my life, Jesus Christ. But I've never really liked monitoring. It always felt to me like, after the fact, clean up. I don't think visually. I don't really think, I don't know, I'd rather do sed and awk and like anything with pipes. I have a hard time going from, here's the problem, here's the solution, now draw a pretty picture of it. That's probably why my design aesthetic is so subtle. I hate monitoring, but I love debugging. Like, I love any day that I get to justify launching strace is like a good day to be alive. I also love firefighting, but I will usually deny it while I'm sober. And Honeycomb is not a monitoring company. People talk like we are all the time, but it's really not how we see ourselves. And this is not a monitoring talk. A couple years ago at Monitorama, Greppery said, monitoring is dead. And I love hyperbolic statements, so I'm going to make a bunch. Put a little asterisk there in your mind. It's like, she doesn't really completely believe this. It's contextual, blah, blah, blah. But that's not as fun as just like planting your flag, right? Monitoring is dead. You heard it here. Monitoring is dead. Whatever. Monitoring systems has not changed significantly in 20 years and has fallen behind the way that we build software. Our software is now large distributed systems made up of many non-uniform interacting components, while the core functionality of monitoring systems has stagnated. This is super true. How many different architectural paradigms have come and gone in the last 20 years? A bunch. Like, I can think of 3 or 4 or 5, depending on how you're going to define them. And yet we still have this model of, I'm going to look at this system, predict how it will fail, write some checks, and done, right? And that's been okay. Like, we've gotten pretty far with it. And I genuinely don't mean to shit on all of the wonderful companies and tools out there that are doing this. Like, they have matured, they have improved, they have gotten better. But they fundamentally answer known unknowns, right? If you have a question, they will answer it, like, real fast. For the past couple of years, I feel like my experience has not been that my issue is with known unknowns. It's with things where I'm like, well, I've got a few problem reports. Some of them might be reliable. Some of them definitely aren't. That one isn't reliable, but I'm suspicious that what they're describing actually could be a problem because of this thing that I'm aware of over here. You know, these things could be correlated. They could all be part of a master plan. Or they could have nothing whatsoever. If I knew what the fucking question was, I could answer it, you know? The entire problem is, what is the question? These are clearly unknown unknowns. These are not ones where you're picking up your phone going, oh, that again, you know, oh, that again. It's more like, what? And for a long-ass time, that was not what dominated the field. Oh, God, now I'm cursing my out-of-orderness because I have a beautiful diagram. Whatever, we'll get to it later. Just mentally bookmark this. So. Anyway, let's take monitoring to mean this for the purposes of this talk. It's the action of observing and checking the behaviors and outputs of a system and its components over time. How many of you are on call? Ever in an on-call rotation? Okay, cool. As you know, it is basically no longer practically possible to curate and tend to the vast volume of paging alerts that we have started generating for ourselves. And this is why nobody wants to be on call, and I don't fucking blame you. It's terrible. It burns out your systems. It burns out your humans, and it doesn't make your systems better. Generating lots of alerts is an outdated pattern. It's an outdated model. So now let's talk about observability. And if you look at Wikipedia, it will tell you that it comes from control theory. If you ask Twitter, it's a marketing term that I made up to sell software. Well, I didn't make it up. I do use it for technical marketing. Thank you very much. Observability is very much about the unknown unknowns. It's about giving yourself all of the components, all the low-level primitives that you need to answer any question that comes up, not just the ones that you could predict or the ones that you've experienced before and you're able to write a check for, right? It's about being able to reason about the insides of your very complex system and understand anything that's happening without having to go and run strace or attach GDB. And like when people complain about having a new term, I think it's important to realize that it's because we have 20 years of best practices built up for monitoring that are really robust and they work really well. And they're often diametrically opposed from the best practices that you have for observability. You want two words because they're two different practices. Now, obviously, both practices can coexist in the same people, the same teams, the same companies, even the same tools can be used for both purposes, but it's very distinct. For example, best practice in monitoring is you should not have to stare at graphs all day. The system should inform you when there's a problem. Legit, super legit. But monitoring is highly biased towards alerts and actionable alerts. Every time you get paged, it's another best practice, it should be actionable. Well, that's cool. But like a lot of the times, if I want to understand something, I don't want an alert for it. It's not necessarily bad, I just want to understand it. Maybe I want to make a decision about what software I want to write or validate a hypothesis. So, oh yes, many of the fun tweets that people have been yammering about. I invented it. No, I invented it. I saw it first and you saw my talk. Whatever. Anyway, this brings me to my own personal definition. This is my spirit animal. I think that observability is very much the software engineers, and this is why this room should care, right? The way monitoring is to operations. And I say this like kicking myself a little because we have spent the last decade telling people monitoring is not just for ops. Okay, it is kind of like monitoring is how you operate services, which is not to say that developers can't do, operate services and all that shit, whatever. But it's about understanding what's happening on the inside by asking questions on the outside. And really building an observable system. Your system is observable to the extent that anything can happen and you can poke around and figure out what's going on. so it's not new. It also, and this is more controversial, there are conventions, there are things that I would strongly argue are associated with observability and observable systems. They're not part of the definition, and you can definitely create observability with other tools, but I think that it is often most effective when it is event-driven. Metrics are a crazy ride that we've been on for the last 20 years because people happen to publish their white papers about metrics, and thus like 1,000 flowers bloomed of time series databases and metrics and dashboards and everything, and we've been using that fucking hammer for every fucking problem for like 2 decades. Sorry. Don't curse. It's hard to remember. So we've been doing that for, but like, these same companies also have tech on event-driven stuff, but they didn't open source their papers because they considered it too core to their business competitiveness. They're better. Their event-driven tools are better, much better. I think that it's inarguable that the health of the system shouldn't actually matter anymore. Metrics dashboards are great for describing the health of the system. They don't tell you anything about the health of the request. Which is why we were dancing around between dashboards and logs and our other tools and just like all this crazy ass shit. You can't do high cardinality with metrics. And high cardinality, for context, cardinality, let's say you have a collection of 100 million users. The highest cardinality will be, unique user ID or social security number. Slightly lower will be first name or last name. Very low cardinality will be gender. And the lowest of all, presumably, would be like species. So what's going to be valuable? Is it the low cardinality information? No. It's the high cardinality information entirely. And the reason that metrics can't really do it is because of the right amplification. A metric is a single number, and then you append tags to help you group. And this is the backbone of everything that has been in the market for the past 20 years for helping you understand your systems. And it is a powerful but limited tool. It was literally what we were left with when we were like, gosh, we have big websites. Hardware is so freaking expensive. I can't store all this on disk. RAM? Forget about it. My 16 megs of RAM are taken. How much can we throw away and still understand anything? And thus the metric was born. Anyway. This is highly controversial, but I believe that this forms the core of any really powerful observability tool. Not coincidentally, it also very much describes honeycomb. I would argue that the causation goes in the opposite direction, but you could find many people to argue with you. I'm a vendor, don't trust me. Software development process. Back to the main plot. This is someone's beautiful, idealized version of how software gets built. Decide, build, and verify. And toss over wall, profit, I guess. I don't know. And the thesis of my talk here is going to be how observability can and should be wrapped into every single part of, oh, not enough unicorns? I'm sorry, there's more. People are walking out already. It's fine. The development process, the first step is usually what needs to be built, what needs to be fixed. The PM sympathizers in the audience would recognize this as the gathering requirements stage. Then how we do it, and then verify my laptop. But finally we want to make sure that this works, right? Usually with tests and benchmarks, QA. And they're important. I'm not trying to downplay the importance of tests at all, but they're isolated and they're very dependent on, again, the known unknowns, the things we can imagine will break, the constraints that we can conceive of. And then we have exceptions. Our reliable signal that something exceptional has happened in production, except it doesn't always mean that, and it's also very limited. Sometimes bad behavior doesn't actually cause exceptions, it just causes your memory to grow forever until it crashes. Or it just increases the latency, or it just, consumes more. And these can be just as exceptional if you let it go on long enough, or it might never even crash, but just provide a really bad experience for someone. Maybe your request ends in 3 seconds, but your timeout was 1 second. And then, of course, ops will tend it forever and ever while you move on to shiny new problems. Just another day in the life of a baller software engineer. See, I'm not so insane about my whole code causes problems thing, right? Like, you are responsible for this piece of shit until you decommission it. From the day that you think of it, all the way through developing it and testing it and hardening it, it's your child. I actually kind of like to think of production systems as like the 4th trimester. You know how in like evolutionary biology, they're like, well, human babies, they're born so weak, they can't even walk. Their 4th trimester, because of their big-ass brains, actually takes place outside the womb. I feel like code, once it's shipped to production, you should do not assume that this child can walk yet. I love you, software engineers. I really, really, really do. But you spend a lot of time looking at fake things. And I get it. Sometimes there are compliance regulations and things that you're helpless. I get it. And then there's just the fact that you've had really shitty tools for, I'm going to stop not trying to curse. It's just impossible. I hereby apologize. You've just had really shitty tools for a long-ass time. Let me tell you a little story about why I actually started this company. Are you guys familiar with Parse, the mobile backend as a service? Yay, Parse fans. So I was the first infrastructure engineer at Parse. I built the systems and I built the teams. I was there through the Facebook acquisition, almost 4 years in total. And we were serving over 1 million users by the time I left. Over 1 million apps hosted on our platform. Love that. Love that product so much. And then Facebook killed it. I am definitely not bitter, ever. No grudges are ever held. Facebook killed it. But before that, when Facebook acquired us, around the time they acquired us, I think we were hosting about 60,000 mobile apps. And that was around the time that I realized with dawning horror that we had built a system that was effectively undebuggable by some of the best engineers in the world, doing all the right things. We had built a thing. All right, so to be fair, let me see if I can, I'll show, I think I have a diagram of that coming up. And you'll see it's like spaghetti, right? It's like, we were doing microservices before there were microservices, and we were running 100 MongoDB replica sets where we let developers all over the world upload their own queries, and we just make it work. Fleet of JavaScript containers where people just upload their own JavaScript, and we just make it work. You could launch a query from inside Cloud Code that would loop back in multiple times and generate queries every time. The fan out was great. We just make it work. Like, never do this. It's a terrible idea. But magic for the developer using it. So it was pretty complicated. And I was running 2 teams at that time, back in the software engineers and production engineers. And every day, I'd get a complaint or a report like, Parse is down. I'd be like, Parse is not down, motherfuckers. Look at my wall full of dashboards. They're all green. There's hardly any errors. Like, we're clearly not down. These people are on crack. Which is always an effective strategy when dealing with your support teams. I'm just losing credibility the longer I argue with them, and I know it, but it's frustrating because every time I would go and investigate or I'd dispatch an engineer, please go and look at this, it would take them a very long time, hours minimum, sometimes days, and they'd just be trying to, anytime you're a platform and you're spending attention and time on one user, you've failed. You should examine your life choices because you did something very wrong. You have to be solving the problems naively. You have to be solving them as a category. And we were spending, I shit you not, 70 or 80% of our collective time tracking down these one-offs, and we were losing ground. And I tried, all right, we were also using Ruby on Rails and MongoDB, which did not help matters, but let's set that aside for now. I tried everything, and finally, the thing that dug us out of the hole was when we got some of our data sets into a tool at Facebook called Scuba. Any Facebook people here, or ex-Facebook? If you ever talk to a Facebook engineer, and or ex-Facebook, and you mention Scuba, look out for the misty look that they get in their eyes. They're just like, oh, yeah, man, that was amazing. They just get shit-eating grin on their face. And to be fair, it's a completely ugly and it's a hostile tool. It does not want you to use it. It's doing its best to be absolutely unusable, and yet all it does is it supports high cardinality grouping, slicing and dicing by fields in memory. So you can just, sort, click, 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 sort in memory. And we reduced the amount of time that it took us to track down these incredibly arcane edge cases from hours or days to seconds or minutes, like reliably. And it was amazing. We got a handle on our shit. We got better. And I just moved along. Like I said, I don't like monitoring. I'm like, finally, on to the next thing. But when I left Facebook, I started realizing I no longer knew how to engineer without a tool like this. Like literally, I'm like, well, I've been out of the world for 4 years. Surely must have come a long way since then. There must be something like this out there because I don't know how to do my job anymore without it. Spoiler alert, there wasn't. And that's why, my grand plan was honestly just, you want to give me money? Okay, I'll go build Scuba, and we'll fail. I'll open source it, and then I'll have it. My COO was like, please stop telling that story, please. It makes you sound like you're not ambitious. But that was the grand plan. It was born out of need. But over the last 2 years, we've been around for 2 years and 2 or 3 weeks, and over the last 2 years, I have become extremely convinced that all y'all are running into this same cliff. You're about to go over it, because microservices are really what I see as our entire industry doubling down on complexity. We're just like, fuck, we can't get any farther. We're just gonna hold our breath and jump, and you have to make every single decision over again. You have to re-examine your entire tooling, your entire pipeline. Everything about how you ship software and understand it has to change in order to deal with this increase in complexity. Where was I? Oh yeah, your development process. The development process is so much more than these first 3 steps. We have to care about what happens in the wild when our code meets real user workloads. And there is no substitute. You can accept no substitute for real production data, real users, talking across the network with real packet loss to other real services. I wanted to make this called Observability-driven development. Christine Nix did. But as the software is being built, these should not be decisions and evaluations that you make at the end when you're shipping it. These should be, you should be forming these hypotheses as you're going, right? At every step of the process, just as much as testing or documentation. You want that feedback loop of, just the way that we are all told to ship changes to Git. You want it to be a small, coherent change that you can then go look at and see, did what I expected to happen actually happen? Did anything else seem to happen around it? Is anything just obviously stabbing me in the eye? And this is where monitoring can't do this. The patterns of monitoring are not these patterns, is a better way to put it, because if you try to create alerts for the combinatorial explosion of thresholds that you may make go up or down, your entire team will quit, and they should. You can't predict it. You shouldn't try. You do need to get in the habit of going to look at it, right? You need this to be muscle memory. You ship something, or your intern ships something, and then you go look at it. And if you're not looking at it when it's normal, you will not know what normal looks like when things actually break. So observability is kind of about helping people define this vocabulary that ops and devs need to share. Normal can mean something different to everyone. You might freak out at the number of errors being thrown, or you might be like, no, that's okay, and here's why. Now, I would definitely argue that there is a threshold of sanity. It should not look the opposite of how it is. Think of it like the Supreme Court reasonable persons test, right? Would a reasonable person think this is pornography? I mean, a system that is outside the bounds of normal, it should look broken if it's broken. It should look not broken if it's not broken. But those are very broad categories. Sometimes normal means including outliers. Sometimes normal means excluding outliers because you know that these users are doing something broken that you are not supporting. Whoop. Yeah, I kind of want to just like the 10 Commandments. So observability isn't just for ops. Just like the dev cycle doesn't end at deploy time. Part of owning our code should be iteratively using data to improve it. The current landscape of tooling is very much designed for and written for ops people. I'm sure you've noticed this, you know? Anything that starts out thinking that load average or CPU time is a useful metric has some pretty, their roots are showing, right? And I mean, ops people shouldn't even think that fucking load average is, whatever. People think that ops people will think that load average is useful or something. I don't know. But like memory utilization, disk utilization, these things are useful, but they don't actually help you figure out things like which build introduced this issue. What special case in the code was triggered? As developers, like we should start demanding that our graphs and underlying data have enough richness and detail that we can track a problem back to the code that caused it. And like on a note, personal note, like this matters to me a lot because, well, a lot of reasons, honestly. It matters to me because I am tired of seeing teams abuse themselves. I'm tired of trying to talk software engineers into understanding their own shit. I am tired of it being so miserable for them to do it. This should be fun. This should be more fun than not knowing it, right? You should get a dopamine hit every time you find something that would have been a user-facing problem, that would have woken you up in the middle of the night. You should be able to find that and go, oh, this is so cool. You know, there are so many just like morsels of delight that you should be stumbling over on any given day, and it angers me that our tooling is so bad. And we've been leaning hard into this mindset for a while, and it has been wonderful. It has been wonderful to get to practice what we preach and to build this culture of asking questions frequently of each other and at every stage of development. So I have some examples of like how we're doing things that I'll just talk through. We ingest lots of structured data. That's another of my religious beliefs, that all data should be structured. I mean, come on. The difference between a structured log and a string is like the difference between grep and all of computer science. I should not have to tell you why this matters. If you don't have a religious zealot about structured data, structured logs in your organization, find one or make one. They should be super annoying. Besides that, we ingest a lot of structured data. We wrote our own storage engine because there's nothing out there that could do the kind of high cardinality analysis that we need, and a highly performant query engine on top of it. We believe that in order for people to be expected to keep an eye on these things, it should be really fast, like sub-second latency for our 95th percentile. We don't want to break someone's flow when they're trying to explore, trying to understand what's happening. You know, we want to feel like, oh, this, so you can just iterate as quickly as your brain can go. It's really important to us. So we spend a lot of time thinking about query performance. We also are selling to businesses. We're a SaaS, so we're selling to businesses who rely on us to understand their systems. So we dog food everything. We only use our own systems to understand our own systems, separated on completely different stacks, of course. We're not idiots. And the nouns, the things that we need to drill down on are often customers, right? This is one of those things where high cardinality, if you can't group by one of each of your 10 million customers, that's a problem. And that really at its root is the thing that fixed everything for us at Parse, is just the ability to break down by that 1 in a million app IDs and then any combination of anything else, right? So you basically, it's like you're pre-generating all of the dashboards and graphs for every single user. Because the only thing that matters to them is how they're experiencing the world, not how your 95th percentile user is experiencing the world, right? So super obvious. Our nouns are customers. You know, so like being able to tie these sorts of concerns has been pretty game-changing for us. Your nouns might be different. Maybe you care about shopping carts, or maybe you care about, expensive raw queries or transactions. But the premise is the same. The most painful problems to debug, the most annoying things to realize, the most important edge cases to understand often originate from that one outlier doing something unexpected. Usually the case is that when things are normal, you don't care about the details. What you care about is the shape and the direction, the curve, the grouping of what's happening. But as soon as something is not going right, then you care about all of the detail. And this is why sampling is so powerful for this case. Did latency increase? Which customers are impacted? Who will benefit from batching? Let's see. Oh, somebody made me, after my strange loop talk, they made this mug, and I fucking love it. So we actually hold ourselves to a much higher understanding of the code that we ship than I think a lot of people do. We try really hard to practice what we preach, and we had our first outage last August. You can look up the postmortem that I wrote. I had been having this mounting sense of dread for 2 or 3 months. I'm like, it's been a year and a half and we haven't had an outage yet. What the fuck is wrong? When it comes, it's going to be so bad. Of course, it was Kafka related when it did come, but yeah, you can read about it. But we don't have outages. We don't really have outages, and I credit that a lot with the fact that we're just always looking at our shit. We have a lot of customers. They're very high traffic, and we don't really go down. We can fail for a user who's doing something in an edge case, but I've totally just jinxed us. I apologize. So let's go through some examples of what we've done at Honeycomb and why I think this is better. Let's see. Query performance. Yeah, so we're constantly looking at individual leaves in our query tree to understand things like, this one data set seems to pop up consistently in this set of recent slow queries. Why? Which queries are slowest? What do they look like? Break down by query shape. Look at the raw, look at the absolute max. This is another thing you cannot do without those raw records. Look at the performance characteristics. And this feels a lot like a business intelligence mindset, It's not one where you're looking at your dashboards and you're just answer. No, you're not paging through the answers. You're starting with a small question, and then you're following the data where it's actually leading you, right? Christine likes to compare it to looking for your keys. Do you start out with a list of the places your keys might be? No, you start looking, and when you remember, sometimes I leave it over there, and you go look over there. Same with debugging. You just start at the edge and work your way down to the lowest point at which there is a problem that's being shared. This is not new computer science. It's just new for systems. Let's see. Yeah. So decide. Decide was the least interesting thing because everybody has a fucking opinion about what you should do, right? Build. So for example, we had some folks ask whether we could unroll their JSON for them. They wanted to send nested JSON. They were hoping we would flatten it for them in flight. Well, we wrote our own storage engine, which means that we can't rely on anyone else in the world having done some things for us, which is unfortunate. Believe me, it was the last resort. And we did not write a database. I'd like to make that perfectly clear. It's not a database. It's a storage engine. There are no transactions. There's no replication. We shell out to rsync. It's a storage engine. Never write a database. Never write a database, unless you're a database company. So it seemed like a pretty straightforward win, but we were worried about the performance impact because anytime that you're taking something small in flight and expanding it, you should be. So instead of just diving in and making the change, we first went and saw how many current customers were doing something that would be impacted by this. That took about 30 seconds. And then we wanted to see how many of those people would actually see a performance decrease instead of an increase. So we added some fields to the payloads to approximate that and let it run for a while to give us information on is there nested JSON, how deep does it go, how many columns are there, how much space would there be if we multiply it. And as it turned out, we had a fairly small number of customers using nested JSON, but they made up a disproportionately large percentage of our traffic. And on top of that, a few of those customers would have ended up with really messy schemas, like hundreds of extra columns, like in a low part of the tree, if we just blindly turned on this obvious improvement. In the end, we made the unfurling opt-in to limit the blast radius. Observability could also help you write less code, which is a winner, always. One day, an engineer was digging into our web apps data set and pulled up, P10, P25, P50, 75, P90, on the round-trip query time from the client's perspective, compared it to from the server's perspective, we realized that the median query time was over 50% the JavaScript active poll interval. So instead of writing a bunch of code, we just dropped that on the client. And immediately, everyone perceived an immense honeycomb speed up. I love it when we get to write less code. And I love these stories because they're kind of like debug statements in your data, right? It's kind of like getting to attach strace to your running system or run GDB live. Like, oh, what a luxury. By having a flow where it's lightweight and natural to add these things to production code in the wild, we can make more informed decisions. Testing your code for correctness is great. Running on your laptop is definitely a thing that it should do. We love feature flags for letting you ship things to production as a first step and making sure that we're still happy with it. It's great because you can ship the code without using it or using it, just for some users. For example, the customer who wanted the unfurled JSON, we shipped it with a feature flag and turned it on just for them because they had already stated they were willing to accept the risk. Terrific. We also add the name of the feature flag just as another dimension for all of our data sets, so we can slice and dice by any combination of anything plus any combination of feature flags. Maybe a change that we're making intersects with one feature flag and not another in unpredictable ways. Let's see, blah, blah, blah. Wow, is it really that late already? I've been talking a lot, haven't I? Okay, I'm going to skip through all this because this is all pretty obvious, I think. So, what's the biggest source of chaos in systems? Well, humans, obviously. Software engineers, you guys, definitely the source of chaos. State of the art for deploys nowadays seems to be just drawing a line in what's happening, which is great. But like I said, metrics, dashboards, high cardinality, they can't support. The ability is actually an infinitely increasing monotonically increasing integer, which is also high cardinality. And everybody has multiple versions running in production at any given time, whether you want to or not. So here's our visualization of just like what happens when we're doing a rolling deploy. Nothing fancy, no canaries or anything. But you can see how there's 3 different versions running there. We have a trigger that we set up that anytime that there's more than 2 versions running in production for more than 10 minutes, it'll let us know. We have not set up automated canaries that graduate as they gain confidence just because we're not large enough, but I highly recommend that. It's probably the #1 thing that you can do to harden your deploys. And deploys, not only are humans the thing that is the source of chaos, but your deploys are responsible for at least half of your outages. Like, they are the things that are the most fragile. Every single deploy is a very unique combination of that artifact, those servers, that environment. You can only test that to some extent, so you should focus on hardening it and adding guardrails instead of actually being too paranoid or focusing on staging. I hate staging environments. I'm going to skip all this. Best practices, though. You want context. You want so much fucking context. You want all the context that you can possibly get. The way Honeycomb does this is anytime your request enters a service, we initialize a Honeycomb event. And then throughout the life of while that request is in that service, you just toss shit in there. Anything you think of that might be useful or interesting. The business nouns, the app ID, the shopping cart ID, anything that is interesting or identifiable. The system stuff, like the raw query, the normalized query family. Any latencies that you get from calling out to any other services or storage layers, and your software engineering nouns too, the build ID, the hash, whatever. Toss it all in there. Hundreds, it's fine, up to the limit of the open file handles in Linux, it's like thousands. And then when the request is exiting the service or errors out, we ship the blob off to Honeycomb. So it's a very low write rate, but the events can be arbitrarily wide. So that's a lot of context. And it's so nice to just be able to go, oh, here is how the system looked when this request happened, instead of trying to go, dashboard, timestamp, oh shit, NTP is off by 1.5 minutes, I'm adjusting for the timestamp. You know, just this like dance of the eyeballs that we do when we're debugging. Context is everything. Finding different ways to group your, if you're not including the attribute or the dimension that is actually the thing that all the things that are broken have in common, it will be as though it does not exist. It will be invisible to you. You will tear your hair out. You will go mad. So just capture everything that you can think of. You know, common source of, common set of nouns, consistent namings, dashes, underscores, whatever you're doing, make it consistent so that people can move fluidly from, you know, system to system and understand what the hell is going on. And this is another kind of honeycombism. So it is a fact of life that when you're building systems to understand other systems, you have to discard some data. Because the amplification, like if you have people who are instrumenting well, for every event that enters your production system, you may generate tens or hundreds of events describing that, right? This is a best practice. Well, I assume you are not going to pay for an observability stack that is tens or hundreds the size of your production stack. Ipso facto, you are going to discard some data. Now, you really have two choices. You can either discard this way or this way. Metrics, dashboards, time series, they have all chosen to discard this way. The older your data get, the less fine-grained it is. The more they've taken everything that happens in an interval and just squished it, right? And once squished, you cannot unsquish. The way that we do it in event worlds is we discard data this way by sampling, which is how scientists do data. You know, people get all, you know, my data. You throw data away every day. Get over it. It's just like saying, you know, what's the temperature in San Francisco? 73 degrees. Well, it's not 73 degrees everywhere. It is 73 degrees in the places that we have agreed are representative of San Francisco. Sampling is everywhere. So for sampling, but what you don't want to do is use it as a blunt instrument, right? You don't want to, not every piece of data is equally valuable. The things that are rare, you want to save all of. The things that are common, you don't. So like, for example, at Parse, we would sample reads heavily in our database traffic, and we would keep every delete, because they were very rare. For like web traffic, 200s, throw a lot away. 500s, keep them all. At Facebook, I think that the sampling ratio, at Parse, the sampling ratio for 200s was like 20 to 1, and at Facebook, it was thousands to 1. But a representative sample is all you need when times are good, because all you really care about is that shape. We also, at Honeycomb, we do the math to, you know, draw the correct numbers in your graphs, just based on the sample rate, which is an attribute in every event. An example, schema evolution. So like, this is us. These are the things that we could predict that we would want. These were some of the fields that we added. And then, you know, we start iterating, added some more, and on and on. So there are going to be a few different kinds of things here. There are the things that you can predict you're going to want, like the HTTP attributes, anything about database queries, any latencies. There's going to be temporary things that you're adding while you're developing to understand and debug your systems. And then there's the things that you add mid-outage that become permanent. Our mission is really this. Stop trying to guess what software to write. Like, do as much of it scientifically as possible. This is the other one. You can tell the difference between Christine's slides and mine. You're a distributed systems engineer now. you're welcome. You should ask for a raise. The other lesson of distributed systems is they're never actually up. They're never all up. If you have a wall full of green dashboards telling you how awesome you are, you should not feel good about yourself because it's lying to you. I mean, you should feel good about yourself, but not because of your dashboards. Okay, I'm basically done, but there's a couple of complexity. So the reason that I think that we are at this tipping point where observability has become important is because the complexity is increasing. I drew this janky-ass graph just because I wanted there to be a graph, because that's how people know things are true. There are graphs. All right, so like, I told you to bookmark this, right? There's a lamp stack on the left, and that is the world that all of our tools that we're used to using were designed in, where we could really fit it in our heads, what we should, which component is broken? Oh, you can tell immediately. In the middle is the diagram of Parse, and this is the electrical grid. And the systems that we're building and designing and trying to understand increasingly look like this, where some problems can only be seen in the hyperlocal level, if you're looking at a city block. Some problems can only be seen if you zoom way out and look at systemic patterns. And your tools need to really speak to both. Unknown unknowns predominate, or they should. Otherwise, you're not doing your job and fixing the things that you know about. And then I have, these slides are all on the web, so you can read through them if you want. These are the best practices, characteristics and best practices. The one that I wanted to jump to is just talking about why the health of the system is irrelevant. I know, it's kind of an inflammatory statement. Health of the system is irrelevant. The health of each event and every high cardinality grouping of each event is what you should care about. If AWS, do you guys use AWS mostly? If an availability zone is down, you should not care. Your users should never notice. This is totally trivial. Your dashboards will all be red, but fuck them. Nobody notices. You shouldn't care. You should sleep blissfully through the night. But if your users are unhappy, if your users are getting errors, or if they're not getting errors, but the experience is terrible, you should care a lot. And this is where the limits of site reliability engineering really come into stark relief. And this is where you guys step in, right? Understanding what our users are experiencing is a prerequisite to making them happy. And the good news is that your reward for embracing all this is vastly fewer paging alerts. You kind of have to declare bankruptcy on the entire model. And if you have confidence in your ability to debug and answer these questions, you should only have to have about 4. Only 4. Request rate, errors, latency, maybe saturation, and then a couple of end-to-end checks that stress the critical path, somewhere around the thing that makes you money. That's it. So, congratulations. Any questions? There's my list of, all right, so if you've ever Googled for how to fix your high cardinality woes, and you find a bunch of people going well, here's how to not have those problems. Those are metrics, people. You can't not have those problems. You can't. Look at this. This is literally all of the kinds of information that you will ever care about. And it is all extremely high cardinality because that's what makes something identifiable. It's rare. So I think that the jig is up on that particular line, in my opinion. Anybody have questions? All right, in that case, I'm just fast forwarding to my favorite memes. I love that one. And this. So we have to test in production. We should embrace this. We should plan for it. We should plan on that 4th trimester being one where we coddle our systems, right? We need to nurture them as they grow up so they can stand on their own 2 feet. Services need owners, not operators. Ops people like me are not going away, but we increasingly live on the other side of the API from you. You know, we're not sitting next to you to save your ass. And I don't want to get woken up anymore either. I'm over 30. Which is why, like, these operational skills are not optional. I believe that no software engineer should be promoted to senior engineering level if they do not demonstrate the ability and desire to own their own systems. Even Android and iOS engineers. Like, this is not a fate of doom. This is how you do your job well, and you should take pride in it, and it's super fun. It's really hella fun. Lots of dopamine involved. Everyone should be interested in what happened to their code after they hit deploy. Watching it run in production. And then Gregory's last 2 slides, or my last 2, which is that when you're thinking about observability and monitoring, think about distributed systems, because, like, if you think about it, distributed systems are really just the computer science of complexity. You know, far-flung data, coordination, graceful degradation, you know, minimizing that critical path. And all of us run systems that are getting massively, massively more complex. So distributed systems will help you future-proof your code. So, thank you.